Okay, so I'd like to follow up with some of the things that we covered last week, some of our basic form finding exercises in Kangaroo, with a couple of precedents that we could try to model using similar techniques. And one of them is the Norman Foster Foundation Droneport that was partly completed already in Rwanda. And you can see that it's characterized by this kind of modular system of these vaulted brick structures. So this is a form that requires form finding in order to accurately produce, and that's very important so that the form that's produced from that process is a structural form. Otherwise, the thinness of this shell would not be possible without some kind of reinforcement. And in this case, it's just brick and mortar. So let's take a look at this and let's get started. If you'd like to know any more about the project, of course, you can go to the Norman Foster Foundation and check out the work. There's a nice video on it as well, and it covers some of the process, the construction methods, the prototype that they built, and so on. Great project. Okay, so we're going to start by just modeling the basic topology. I'm going to start in the top view. I'm in inches, so you may want to follow along. I'm going to grab a mesh, so I'm going to go to Mesh, Polygon Primitives, Plane, and before I start clicking around, I'm going to change the X count up top to 15 by 15 in the Y. Okay, so 15 by 15. I think this is just a better resolution for what we're trying to do. And then I'm going to hold Shift as I click from one corner to the other, like this. And the size doesn't really matter, but I'm just going to go off to something around there. And I'm going to turn this on ghosted so we can take a look at this. So now we've created a mesh plane. The other thing I'm going to make sure that you guys have on is the vertex object snap down at the bottom here. The only way to snap to mesh points is to turn this on, because technically they're a slightly different thing than points. They're called vertices or a vertex. And the next thing I'm going to do is I'm just going to put a point at all the corners, and this may be an important reference for later. And then I'm going to draw a circle from that point to that vertex, which is just 2 mesh faces away from the corner like that. And I just clicked right to that edge. So you can see that I've drawn basically a radius, or an arc, I should say, from that point down tangentially to that point there. Okay, and I'm going to do that for all 4 corners, so actually I can just copy that circle around like this. Now what I'm doing is setting up the kind of base condition for the shell structure. You can kind of see it a little bit here. It's hard to tell that there's a curve there, but if you look at the actual the proposal for this, you can see that actually there's a curve between the vaulted areas here. So the openings that are vaulted transitions to this doubly curved area here, which then bends back out to become the arch above. And what I'm going to do then is erode away at this mesh a little bit so we have a better shape so we can produce something like that. So I'm going to type in delete, and the second option down is delete mesh faces, at least on my screen. So write up the delete mesh faces command and just delete those 4 faces on each corner like this. And now we have an object that looks a bit like that. I'm also going to, because we're going to need this later, I'm going to put a single point, well, I'm going to put a series of points at the vertices that that outline those curves at each corner like this. And this will become clear a little bit later when we start the Kangaroo work. Okay. The other thing I'm going to do is add a series of points on the edges. And there are quicker ways to do this using some components in Grasshopper, but sometimes I like to just work manually to get started. Because it doesn't take very long. And we can just do it on the 2 outer edges, let's say the left and right edge, I should say, and you don't have to put any points yet in for the top and bottom edges. We'll leave those free for now. Okay, so we have our base polygon, and we have our base setup in terms of our anchors. Well, actually, there's one more step. I'm going to turn this on to ghosted in this view. We just need to trim away at this circle. We don't actually need the entire circle anymore. So I'm going to type in trim. The cutting objects can be these 2 points here. And then I'm just going to get rid of that like that. So go ahead and do that for all 4 corners. Use those points you drew and just chop away at those circles. Cool. Okay, now we're pretty much ready to get started in Kangaroo. So I'm going to open up Grasshopper. The first thing I'm going to do is just kind of start bringing in some of these objects here. So I'm going to grab in geometry, I'll grab the mesh parameter and bring my mesh in. And I'm just going to hide that now that it's in. And then I'm going to bring in a set of points that will end up being my anchor points. Points I don't want to move, points that will anchor the structure to the ground. And so follow along. This gets, it's important that we do this in the right order, and I'll show you why in a bit. Okay, so I'm just going to right click on that, set multiple points, and I'm just going to select the ends, if you will, of the arcs. Just the ends. These other ones we'll use for something else. So I'm going to go ahead and click around like this and just select those points. These points I don't want to move ever. These other points I have other plans for, which will be next. Okay, so we set those points in. Those are our anchors. In fact, we could label that anchors if we'd like, just to make sure we don't forget. And I'm going to bring in the rest of those points, and those are going to be something else. So I'm going to grab another one of those point parameters. And here's where the order really matters. So check this out before you start working. So I'm going to set multiple points, and I'm going to start, just because I'm closest to it, I'm going to start with the bottom left corner. And I'm going to work my way around counterclockwise. The order for this sort of matters in terms of what you associate with what. So what we're going to try to do is put these points and force them to interact with that curve. And to do that, we need to tell Kangaroo that these points interact with this curve, these points interact with that curve, and so on. But these points should never interact with any other curve. So that's why we need to know what order things are in. So this is the one rule about kind of working manually for Kangaroo setup, is that you need to be a little bit more careful, I suppose, with what order you're selecting your points in when you bring them in. So I'm going to select those 3 first. I'm going to go to the next one over here, just remembering that this is the order that I chose. And now, you can use whatever order you like, so long as you remember what order it is. Okay, and I'm going to always swing myself back to where I started so I don't forget. Okay, so those points are in, and I'm going to call these pull points. Okay, and then before I forget, I'm going to grab the curve parameter, and I'm going to set those curves in the exact same order. So set multiple curves, starting in that corner, working to this corner, that corner, and that corner. And I'm going to swing myself back around to where I started, and there we go. So now I know that the order, at least, of these lists are aligned. However, we have more points here than we have curves, right? So we have 4 curves, and we've got 12 points. So what we can do is partition this list to make 4 lists that align themselves to these 4 curves. So we'll go to set, list, partition. We're going to partition this list, and we know how many times we want to partition it, which is 3, because we're trying to associate 3 points with each thing. Oops. Yeah. Like that. So now I've got a different data set coming out of here, right? Now I have my points are still there, but they're now been organized into 4 different lists, which I can align with these 4 different curves. So that's nice. I'm going to leave those things connected to one another like that, kind of align these things, and I got a nice setup to start. All right. So I'm going to start the Kangaroo setup. I'm going to head over to Kangaroo like before. In this case, I'm going to use the bouncy solver. I like to see how this simulates a little more slowly. I'm going to set that over here like we always do. I'm going to grab the Boolean toggle and the button so I can do my resets and my turn this thing on and off as I'd like. And I'm going to leave it off for now. All right. Okay. And then I'm going to grab an anchor, Kangaroo 2, anchor. I'm going to make these anchors, put these into the simulation. And the next thing then would be to set up our mesh. And we can do this the sort of faster way in this case. Last time I showed you it's the same exact result just by giving all the edges in the mesh basically making them act like springs. This time I'm just going to go into goals-mesh and just grab this edge length component here, which does more or less the same thing. It just gives me a little less control over the outcome, but that's okay in this case. Our length factor can be anything between 0 and 1, so I'm just going to grab a typical slider and maybe put that up a little bit. Strength, we can leave at 1 for now, and go ahead and drop that into the goals, holding Shift. And the other thing we'd like to do is look at the mesh when we simulate it, so I'm going to do this. And I'm going to wait to put that one into the goal objects, and you'll see why in just a second. All right, and then I'm going to do something with this stuff. So I'm going to go to Kangaroo, goals-on, and we're going to look for the on curve component. The curve that we want to deal with are these here, but I have to make sure that my data sets match. So here I have one list, here I have 4 lists. So go ahead and right-click on the curve parameter and just click graft. That's the upward arrow. And you can connect that into our curve input, and then we can connect the output of the partition back into the points input of that component. The next thing we'll do is we'll up the strength on this, because I know that we'll need it to be strong. I'm just going to make it 500 and see how that looks. All right, and I'm going to drop this in like so. So we can go ahead and see what it does, and if we turn that on, if I turn my mesh off here for a second, yeah, we can see that we've added the forces, so this tension in this length factor here is being applied, and it's being applied between all the anchor points. And what also is happening is I'm pulling those other 3 points, you can see it here, to that curve, and if I reset, you'll see it more clearly. Yeah. So that's giving us our nice kind of bend in the plan, or in the way that it meets the ground. It's giving us that nice little curve that we'll need for structure. When we inflate this into a dome-like form, this will maintain its curvature. So let's go ahead and give that a force to deal with. There's a couple ways to do that as well, of course, but let's head into Kangaroo again. This time I'm going to go to my mesh utilities. I'm going to grab the naked vertices from our mesh to apply the clothed vertices. So this component separates the edges against the interior points, which is what's called clothed or naked. I'm going to go with the the clothed ones and apply some forces to that. We probably could do this using Weaverbird as well, but I'd like to show you this component because it's also very useful for certain kinds of things when you have to distinguish between edges and interiors, which we're going to do a little bit later on in this tutorial. And I'm going to apply a load to those points. So the clothed points will be here. I'm going to there, and I got this component in the goals point tab there. By the way, if you're looking for any components that I may have said but I didn't maybe describe where I got them, you can hold Control-Alt and click on the component, and you'll see where things come from. In case you're opening up sample scripts, things like that from people and you don't really know where things are found. I also just realized that I've been using icons. I hope that's not too confusing for you guys. I'm going to keep going with the icons. It's good to get used to these as well, but if you're comfortable with a different display option, please feel free to use these. It doesn't affect anything aside from the visualization. I need to give this a force, so I'm going to double click and just type Z. That'll be my positive Z direction, and then I'm going to put a slider into this so I can give it some magnitude. And I'm going to add this to my goals. So now what we're seeing is the inflation of the mesh and the form starting to take shape. And now again, this is a combination of forces being applied. So as this increases, of course, the mesh wants to get taller, it wants to stretch more, and that's because the relationship between the strength of these lines and the strength of that force is producing that outcome. If I increase that strength a little bit, I'll get a slightly different form at the edge. You can see it really pulling in more, but I'll also reduce its height. So this is the kind of form finding process. Now you can also see that we have a situation where we're starting to bend inward quite a bit, which is kind of expected, given what we're doing here. But our case study doesn't do that, does it? It actually keeps a strong edge on all of these. So these are orthogonal to that elevation. So that comes up straight, and this comes up straight, and so on. So let's do that next. And to do this, actually, we got to take a step back just for a second and show our mesh one more time. I actually should have had you draw these points, because I jumped the gun into the next step. But yeah, go ahead and produce a set of points like we did before along the edges on all four sides, like that. I might as well show this all the way around. And the reason why we're not using the naked points that are coming out of this component to do this is because it also selects these here that we don't want to affect in the next step. We want these to be able to move freely to that curve. What I'm going to do is constrain the movement of these points to move only in the Z direction. But if you're not doing stuff like that with this kind of pull, you can just use this component in order to kind of pull to do the next step. But I find this to be just fine to work manually because it's really pretty quick. Okay, so I've added all those points, and I'm going to start bringing those into Grasshopper. So I'm going to grab another point parameter, set multiples, and the order here doesn't really matter. And I'm just going to kind of batch select all the points at the edges like this. Okay. So those are now in, and I can label these, I guess, our edge points. Keep me organized. Okay. All right, now we're going to go back into Kangaroo and grab in the goals point, you'll see this anchor XYZ. So it's a different type of anchor. And this one allows us to set constraints that aren't in the other component. So in here, if I add any of these to be true, it'll prevent movement in that direction. I want to prevent movement in the X and Y direction and only allow movement in the Z. So I'm going to grab a Boolean toggle from up here and turn that true, and then put that both into my X and my Z here. Or sorry, my X and my Y. And I'm going to add that to my goals. And now we can see we've pretty aggressively forced those points to not move in any other direction but the Z direction directly upward. And that stretched our dome-like form out to resemble a lot more of what we're seeing in the Droneport. The strength on this is already at 1,000, so you probably don't need to add anything to that. And at this point, what we can now do is just start experimenting a little bit with the form. I can make it a little taller. I can change its proportions ever so slightly. Now we're still seeing a wireframe, so let's go ahead and add that light bulb component to our goals. And now we're going to look at that mesh. And let's look at what the output is here. We're getting a bunch of stuff, and this is pretty common. The goal function outputs doesn't always output geometry. Sometimes it outputs forces and stuff that will come in, and numerical data sometimes will come out, but sometimes it comes out as null. What I usually do to clean this up a little bit and to select maybe only the mesh and without all of the points is to head into my Set tab, go to Tree, go to Clean Tree. I'm going to turn off my solver. And what I'm now outputting is just, and I'm going to actually turn that to true as well, that probably don't have to, but Now what I'm outputting is just the geometry that's coming out, not all the nulls and the vertices. The vertices are handily, they're separated for us. So if I turn this component off in terms of its preview, I can remove all that point data coming out so I can see a cleaner version of it. And if I only wanted to select the mesh, you can see that it's at the top of that list there. And that's because I added it last to the goal objects. So if we wanted to select, or to distinguish at least between the lines in the mesh, you could do that just by selecting this. And now we're only outputting the mesh. There are other clever methods to, I mean, I could also partition this or split this list to do the baking if I wanted just the curves to come out. I guess while I'm here, I can show you that. Sometimes it comes out as a tree, and that's pretty helpful. It all depends on how you put it into here, and maybe I can cover that in a different tutorial. But for now, what I'll do is I'm just going to split this list with the index of, I don't know if it's going to be 1 or 0. Let's try 1. Yeah, so if I put in an index of 1, delete that other one. Here, I'll make that clear also just by showing you this so that it's on screen at all times. In the A output, I've got the mesh, and in the B, I've got all my lines. So if I wanted to, I could just simply bake these out independently from the mesh. And now these two things have been separated for baking and further post-production. Yeah, and you can also start seeing how we're getting this nice kind of, I mean, it's domed like here, but it's starting to curve back a little bit there. And that's pretty close to what we're looking at with the Droneport structurally and formally. We're also getting the nice curve down below here. And I think we're getting real close. Now, we could add resolution to this mesh. I mean, this goes all the way back to the beginning. If you think this is too coarse, you could subdivide this a little further using the Refine tab. I'm not going to do that because I don't think it's necessary. The simulation's working just fine here. But just for your future reference, you could refine that mesh a little further. You can see now that it's a little bit more dense. It's going to change the forces. You'll have to adjust your forces if you do this. You know, if you change your topology to be a little more dense, but it's an option. And the other thing you can do is smooth after the form finding, which is pretty common for, let's say, for renderings and drawings. If you're really comfortable with the way this is coming out, you know, we can use Weaverbird maybe to just add some density after the fact. And in that case, what you're going to want to do is extract these lines from that mesh. So don't be, you know, as you're building new meshes and you're extracting information, you have to know which mesh you're extracting from in order to get the right stuff. So keep yourself organized. The other thing we're seeing is when we do this Weaverbird stuff is that, you know, our corner points are starting to erode. So we could just make sure that's on fixed. And so if you right click on the S input, you'll find fixed there, and you'll see that that's now reconnected. Very nice. So the next thing I want to do now that we've got a nice form and we've got a module working, we know that we're barking up the right tree here. What I'd like to do now is connect a couple of these together in order to get this little undulation going on in here. So we'll look at how we can do that in the next set of steps. So what I'm going to do now that this step is all set, what you should do is save. Go ahead and give this thing a save. You know, call it what you like. I'm going to call it just DP for Droneport. I'm just going to call it step 1. And save that out. So, because the next step we're going to add to this, and we want to keep an archive of our progress always. All right, and then I'm going to just hit this little green and gray cylinder up here to kind of turn off my preview for everything, because I don't need to see this right now. And I'm going to turn off Kangaroo just to pause it so that it's not running anything. And I'm going to minimize Grasshopper. And then I'm going to show all the stuff that I hid in order to keep going. So the next step is relatively straightforward. We're just going to make a copy of the stuff we have here. And so I'm going to do this. I'm going to take all that. I'm going to copy it. And I'm going to copy it from that corner point to this corner point, thereby extending our base mesh to have two domes connected. And then because I've got duplicate points here, because I just made a copy, I'm just going to type in SEL dup, DUP, select dupe, and then just delete those duplicates. If I run that command again, it should find that I have no duplicates in the system. Good. I also probably don't need these points anymore, but we can leave them. And now we just need to do a little bit reshuffling a little bit of what points relate to the curves, what our anchors are, and so on in the system, because we've now added something. And it's easier, I think, to just restart that process. So I'm going to go into Grasshopper. Things have gone red now because our edge points have changed, because I've made a change in Rhino. But that's fine. So go ahead and just right-click on these on anything that went orange and just clear those values out. The pull points, we can also clear those out because we're going to redo those as well. And we can also clear out the curves because we're going to redo those too. Okay, so let's start with the anchors. This one's easier. I'm going to right-click to set those anchors, multiple points, and the anchors are going to be the same as I did before, so just these outer ones. I think we can set this one as an anchor. Yeah, let's set that as an anchor too, like that, and so that it's just this one, that one, and that one. So anything that kind of, any endpoint of the arcs we'll set as anchors. But only do that for this center area here, not for the other areas in the corners. Okay, like that. All right. I'm going to go back to where I started. And now I'm going to set my pull points. Right-click, multiple points. And then I'm just going to select those three. Those three. All right. These three and all the way around. Okay. Cool. All right. And now we're going to have to change it. Well, actually, our partition should be fine because it's still 3 points. And there's 8 curves. So all of this should be fine. And now all we got to do is set these curves in the same order. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So now we're back to where we were before. I'm going to hide these. Actually, nope, don't hide those. We're going to need those. Clear out the mesh object as well. Forgot we have to do that. So we got to clear these, and then we got to add 2 meshes to this. 1 and 2. And now we can hide these. All right. What's the last step? Our edge points. In this case, we're just going to select those and these. The center ones, we want to let that naturally do its thing because now it's connected to another mesh down the line. So let's select these multiple points on this end, like that, and on the other side, like that. And I guess we can also do that for the front ones as well. And again, it doesn't matter in this case what order they're in. We just need to constrain them. So I'm just selecting all those edge points, as you can see. Cool. All right, and let's turn that thing off. Okay, it looks like, yeah, what we're doing is we're not visualizing. So back to when we had all this stuff going on over here, I was only selecting one of those meshes, but now we have 2. So let's take a look at the data coming out here. Okay, a bunch of nulls, whatever. Let's take a look at this. Okay, yeah, so we got 2 meshes coming up top there. So I'm going to split this at the second. There we go. So now I can split that into the 2 meshes and all my lines. And it looks like now I don't have any issues seeing at least what's coming out of Kangaroo. Go ahead and turn that to true. And watch it bounce around a little bit. The other thing I want to do, I like that I'm seeing the simulation, but the bounciness for me is not all that great. So what I'm going to do is change the damping here to something a little bit lower. And if I do that and then reset it, you'll see this is going to go super slow because I've changed the damping to something really low. But I like the way, that simulates. So I'm just going to quicken this up a little bit by putting it up to like 0.9, 0.9, and reset that. And I kind of like the way that feels, especially if you're going to do an animation or something. This is quite a nice way of doing it. So now we've got two meshes connected. If we look toward the center, we can see that we've got something going on here that's almost what we want. But you can see that there's a seam. You can almost tell that this has been basically two objects that came together. And this is probably more likely to be in the built product when they add. So these are intended to be built one at a time, as we saw with this diagram down here. And it's likely that there will be something visible there, although it depends on how they make this end condition work. But in the brick coursing, you'd probably see a seam anyhow. But in this rendering, I'd like to try to and you can kind of see it also happening here, where it's quite clear that there's different domes. But I really like this, and I want to try to get that form to emerge. And it's a simple thing, in this case at least, the way we set it up. If we look at the output again, we've got two meshes coming out that are separate. This is what's called, but they're being simulated together. That's what's called a disjoint mesh. And they're just disjointed, but they're working in tandem. But they're not transferring necessarily forces together. Well, that might not be true. Maybe they are. But in any case, they're not acting as a single mesh. So that's a simple thing. All we got to do is head over to Kangaroo. And there's a couple ways to do this, but I like the Kangaroo component. We can go to the utility again, the mesh utility, and grab this combine and clean. And before I start connecting anything to that, I'm going to speed this process up by holding Control and Shift, and you see the little arrow turning white, and then I can take all of those outputs and put them into a different component. And of course all that's going to go dead for a second, but just reconnect. Okay. And now that I've reconnected that, and I've made one mesh out of two, you can see that I'm getting the kind of undulation and the curvature as we were looking for. I can play with the forms, maybe add some height, reduce this a bit, and I'm getting even more undulation. Very beautiful. There is one more thing I'd like to do in this, and this is just kind of a bonus. And after I do one of them, you can go ahead and try this out on some of the other parts, and you can make this thing as long as you'd like. But what we're also seeing in the Droneport, I think, is that these are lower than these. And it's tough to tell which one was the naturally found arch. I mean, it could be that they're both controlled. But just for the sake of example, I'm going to show you how we can increase this arch while keeping this one at a different height, just by using the same goal that we use down here to keep these points on that curve here. So, yep, those points are still. So what I'm going to do is focus on just one of these arches on the side here, and I'm going to grab another point parameter. And I'm going to select 2 points here, just these kind of two anchors that we have in before, because I'm going to use those as endpoints for a curve I'm going to draw. And I'm going to call these the catenary points. You can call them, yeah, call them the catenary points. Catenary. Okay. And then I'm going to go to my Set tab, grab this list component. This is just a list item component, the one over here, list item. I'm going to zoom in, hit the plus sign. I can turn that off. And to do a couple things, I'm going to draw myself a catenary. And to set that up, I need to figure out how far apart they are from one another. So I'm going to go to vector, distance. That's the distance that they are apart. I'm going to then go to math. I'm going to add the addition, so the plus symbol. Okay. And then I'm going to put a slider on that between, I don't know, so double click, just type in, let's say 25. That's probably going to be pretty high, but that's okay. And I'm going to go to curve and find my catenary command. Let's see, yeah, it's under spline, so curve, spline, catenary. And let's see what it looks for. It's looking for a start point and an end point, so we know that that's this point and that point. It's looking for a length, and that's what's going to come out of this. So what we found is our shortest length, which is our distance, and we're adding length to that. And you can see that by default it's kind of hanging. So this simulates, in a way simulates, but it mathematically approximates a hanging chain, which if you were to, you may have learned already in structures or in another course, maybe in ARC history, how catenaries work. This is just simply hanging a chain from 2 points will produce a form in perfect tension, and if you flip that, it's a form in perfect compression. But this is a shape that's optimized for its own self-weight, whereas if you were designing a bridge or something, you would not use a catenary curve. More than likely, you would use a parabolic curve, which can take more loading, active loading. In any case, we're going to use the catenary curve as a way to draw out a curve that we're going to use to constrain this one here, this side there. And then for my direction, all I got to do is just swap that, so I can just put a z direction in here, positive, and it'll flip up for me. And you can see that there. And just to stay somewhat organized, I'm going to go to display. I'm going to put a custom preview on that curve so I can always find it, really quickly. There we go. All right. Very nice. Last thing we need to do is grab another point parameter and select multiple points. And what we're going to do is take these edge points and we're going to force those to interact with the curve we just drew. Okay. And that's those. So I'm going to call these just the cat pole. I'm going to go back to kangaroo, grab that same component on curve. These are the points. This is the curve. And let's add it to our simulation. And now you can see that it reacted ever so slightly. It's trying. And it worked up here, but it's fighting down here. And that's just because our strength is pretty low. So let's go ahead and crank that strength up a bit like we did before. I'm going to just grab another panel and throw in 500. And you can see now that it's been tied, if you will, right to that edge, or pretty close to it, which is good enough. And now I'm going to just go to a different view here to show you how it works. If I add length to that catenary, I'm also adding height to the outer arch, that edge arch, which is now at a different height than this one, which was found naturally through the form finding process. Now I can also lower this. I can add the same kind of functionality to these sides and actually really fine-tune the height of all the arches all the way around the architecture, all the way around the structure. So in a way, it's natural form finding, but with pretty simple constraints. If you were to build a model like this or something, and if you were to hang catenary curves from points, if you were to imagine this whole thing upside down, and you were to hang catenary curves from these points, and then try to connect a hanging chain mesh in between all of those, in between the connecting the edges to the catenaries and hanging weight off of that, if it were slightly elastic, you'd probably end up with a form that were somewhat similar to this. So with any kind of form finding experiment, especially physical models, there's always a set of constraints. And that's very true also for the way you work digitally. But in any case, this is the end of this tutorial. This system could continue on and you can fine-tune it. You can also use the same setup, a very similar setup to the one I used, with the mesh, the curves, the anchors in the right places, in order to produce different kinds of outcomes. So different scaled arches, different scaled domes, different undulations, potentially even curvature and plan if you like. So there's ways to experiment with this setup. Feel free to do so, or just kind of continue on, maybe add a third. See if you can challenge yourself to add a third dome on the right here, or maybe even add one in kind of an L-shaped formation over here, using the kind of same setup that we used. So feel free to experiment a little bit with it. In any case, produce a nice drawing of what we've made, or a nice screenshot of what we made. And also take a look at the Droneport project by Foster+Partners. Okay.